Alright, let's take a look at question number 6. It reads, function A and function B are continuous quadratic functions. And we can see both functions presented in different representations here. Function A is presented in algebraic format and function B is presented graphically. Question: which function has a greater positive x-intercept? So let's start with function A. What is the x-intercept of a quadratic function presented in algebraic form? So one reminder is as follows. The x-intercepts for a quadratic function are the solutions to f of x equals 0. So basically you're looking for the zeros or roots of a quadratic function. Those are also your x-intercepts. Okay? So let's go ahead and find out what the roots of the function A are. Okay? So function A, we're going to set the function f of x equals x squared minus x minus 6 to 0. Okay? So let's go ahead and do that. So we have the function, and then we're going to set it equal to 0. So x squared minus x minus 6 equals 0. So this is a quadratic trinomial. So the method we're going to use to solve this is the x game, okay? So we want to express it as 4 terms so we can factor by grouping. So AC goes on top, negative 6, B goes on the bottom, negative 1. Two numbers that multiply to yield negative 6 and add to give 1 are 2 and negative 3. Now in this particular problem, A has a value of 1, which means we do not have to factor by grouping. We can skip that step and jump all the way to the factored state, which is going to be x plus 2, extracting this 2 from our x game, and x minus 3. Both the product equals 0. Now we're going to use the zero product property to finish off this problem. X plus 2 equals 0 and x minus 3 equals 0. If we solve the first equation by subtracting 2 from both sides, we have x equals negative 2. And if we add 3 to both sides here, we have x equals positive 3. Alrighty, so the x-intercepts for function A are negative 2 and 3. So x-intercepts for A are negative 2 and 3. Now how about the x-intercepts for function B? We can easily determine what the x-intercepts are if the representation is in graphical form. Alright, so graphically the x-intercepts are basically the x-coordinates of the points where the graph intersects the x-axis. Okay, those are your x-intercepts. So this has a value of 2 and this has a value of negative 3. So for function B, the x-intercepts are negative 3 and 2. So let's go ahead and write it down, negative 3 and 2. So back to the question, which function has a greater positive x-intercept? So our focus is on comparing these two positive x-intercept values of the two functions. We can clearly see that the a function has a bigger x-intercept when we're considering the positive ones. Alright, so that's our answer. Answer is option A, because function A has a greater x-intercept of positive 3 compared to the 2 for function letter B. Alright, let's take a look at question 7. It reads, what is the equation of the parabola shown? So we have a parabolic function graphed here, and we have 4 options, and one of these options is the algebraic representation of this parabolic curve that's sketched here. So one thing you want to keep in mind, if you have a bunch of quadratic functions and a parabolic function graph with points, the correct one is basically the function that satisfies the points given. Okay, so let's write that down. Little tip here, the correct equation is the one that satisfies all points on the function, all points on the graph. Alright, so the nice thing about this problem is we're given 2 points, so we are just going to test these two, and those should be sufficient to determine what the correct answer is. Alright, so let's start out with option A. So it has to satisfy, so let's just put a remark down before we start so we know exactly what we're doing. Okay, the correct equation must satisfy the 2 points given. The first one is the origin, 0, 0. Okay, this is 0, 0. And the second one is positive 1, negative 2. So what does it mean to satisfy? Satisfying an equation basically means that if you plug in the points, you end up with a true statement. So let's look at option A, y equals negative 4x squared. Let's see if the equation satisfies these 2 points. Let's start with the first one, 0, 0. So we're simply plugging in 0 for x and 0 for y. Let's go ahead and do that and see what we get. We will have 0 for the y equals negative 4 times 0 for the x squared. Simplify this, you have 0 equals 0, so that's good. Now since the equation satisfies the first coordinate, does that automatically mean that it's the correct answer? The answer is no. We have to test the second coordinate pair. Okay, so we have 1, negative 2. When we substitute the x and the y values, you have for the y as negative 2 equals negative 4 times the x value of 1 square. Okay, is negative 2 equals negative 4 times 1 square is just negative 4 times 1, which is negative 4. Is this statement true? This is false. Okay, so function A does not satisfy both points, so it is not the equation of this graph. Moving along to option B, we have y equals negative 2x squared. Now let's go ahead and see if this equation satisfies both points. The first one, 0, 0. Substitute 0 for the y, we have 0 equals negative 2 times, if we substitute 0 for the x, 0 squared. So we have 0 equals, if you simplify this, entire expression to the right, you end up with 0. And this is a true statement, so the equation satisfies the first coordinate pair. We have to test the second one, okay? Second one is 1 comma negative 2. Y coordinate is negative 2. We're plugging it into this function, okay? So negative 2 equals negative 2 times 1 square. If you simplify that, you have negative 2 equals negative 2, and that's excellent. It satisfies both. Our answer is option letter B. If you like, you can test C and D. You'll see that neither of them satisfy the second coordinate pair. Alright, let's take a look at question number 8. We're asked to factor a quadratic binomial here. So before we factor it, just note the following formulas, okay? So the first one is known as the difference of squares formula, a squared minus b squared, which factors into a plus b times a minus b. Now, if you have a sum of squares, something strange happens. Using real coefficients, we cannot factor this. This is prime. But if we extend our set of coefficients to complex numbers, then it's factorable. If we factor a squared plus b squared, you're going to have something strange happening. You're going to have a plus bi multiplied by a minus bi. So this is the factored form of the sum of squares. You can notice that you have the i's there. So this idea is what we're going to be applying to this situation here. So we have 9x squared plus 121. Since it is a sum of squares, it's kind of like an oddity. Its factored state will have i's in them. Alright, so let's go ahead and factor it out. We'll do this by taking the square root of the first and the last term. Square root of 9x squared is 3x, so we have 3x plus square root of 121 is 11. Since we're dealing with the sum of squares, we have to put an I in there. And then we will also write this as a difference, 3x minus 11i. Answer to question number 8 is option letter D. Okay, let's take a look at question 9. We're to solve the equation 6x squared plus 24x equals 126. So let's solve it by factoring. So we have 6x squared plus 24x equals 126. Now, if we want to solve this by factoring, first thing to do is to put it in standard form. Set it equal to 0 with decreasing order of degrees. So subtract 126 from both sides, and we have the quadratic in standard form, 6x squared plus 24x minus 126 equals 0. Now, to simplify the factorization and solving process, it's always beneficial to see if your quadratic equation can be reduced. Is there a greatest common factor that we can divide all three terms by to express the equation in a simplified state? The answer is yes. 6 goes evenly, divides every single integer evenly, so we're going to divide every single term by 6, and that gives us x squared plus 4x minus 21 equals 0. It's much easier to deal with this. Okay, now we're going to go ahead and use the x game since we're dealing with a quadratic trinomial. AC goes on top. AC is negative 21. B is positive 4. The two numbers that work here, that multiply to give you negative 21 and add to give you positive 4, are 7 and negative 3. Now, since A is equal to 1 again, we do not have to factor by grouping. We can skip straight to the factored state. X plus 7 times x minus 3 equals 0. Using the zero product property, we'll set both factors equal to 0 and solve. First one, subtract 7 from both sides, x equals negative 7. And this one, you add 3 to both sides, x equals positive 3. So these are the solutions to your quadratic equation. Our answer is option letter B. Okay, let's take a look at question 10. It says, solve the quadratic equation by taking the square root. So we have the quadratic equation for x squared plus 5 equals negative 1. So to take the square root, what we are going to do first is attempt to isolate x squared so we can take the square root and get what the value of x is. Step 1, subtract 5 from both sides. That gives us 4x squared equals negative 6. And then we'll divide both sides by 4. Okay, that gives us x squared. And then we have negative 6 over 4. To get x isolated, we're going to take the square root of both sides of the equation. So you have square root, and square root. Notice I didn't reduce 6 over 4 because we're going to be taking the square root, and reducing this fraction will make the problem solving process a little bit longer. You still get the same answer, but it'll be longer. Okay, so let's see. Anytime you take the square root of a square, what must you introduce to your equation? You must introduce plus or minus. Okay, and whenever you take the square root of negative, that negative comes out as I. 6 is not a perfect square and cannot be reduced. So we'll leave it as root 6. Square root of 4 is 2. So there goes our answer. X is plus or minus I root 6 over 2. Option letter C is the answer to question number 10. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your preparation for your upcoming semester 1 exam, do give us a thumbs up. Your positive feedback is very important to us. If you have any questions or comments concerning what we covered in this clip, do give us place a comment in the comment section below and we'll be more than glad to respond. We update great math tutorials to our YouTube page on a regular basis, so subscribe to our channel so you can get notification of updates. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day. Goodbye.